Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In today's class, we are going to learn about how to find a trick to find hybridization of coordination complexes. So, to know the hybridization, how we can easily find the hybridization of coordination complexes. Yes, let us start now. Before going to the trick of finding the hybridization, you should know these two steps. This is the main important trick that you should remember, children. To find the hybridization of the coordination complexes, you need to know the step number 1, that is to find the oxidation number of the central metal atom. First, you need to find the oxidation number. You know very well. I have taught you how to do this in the previous video. And the step number 2, identify the type of ligand. There are two types of ligand, children. One is a weak field ligand, the other one is a strong field ligand. Whenever there is a weak field ligand, the electrons of the central metal atom do not undergo pairing. No pairing takes place. Whenever there is a strong field ligand, the electrons of the central metal atom undergo pairing. Remember, some of the common examples of weak field ligand is fluoride, fluorido, chlorido, thiocyanado, bromido. Some of the strong field ligand, cyanide, ethane 1,2 diamine, NH3, EDTA, etc. Commonly we use for these more ligands, we are going to find the hybridization. So after following the step number 1 and step number 2, you also should know the electronic configuration. Try to memorize this electronic configuration, children. Try to memorize the electronic configuration of these elements. Central metal atom. Central metal atom of cobalt, you can see 3d7 4s2 argon, nickel argon 3d8 4s2. Like that we have nickel, chromium, iron, silver, copper, manganese, platinum, vanadium. At least try to remember these elements electronic configuration, which will be very much helpful for you. I'll just tell you how to make use of this, and let us start following the step number 1 and step number 2 with the one example, so that you can understand the better the step number 1 and step number 2. Let us try one example here, children. Let us learn how to find the hybridization of this given example. So as I mentioned, the step number 1, that is to find the oxidation number of the central metal atom. So it is very easy. Let us see and let us follow the step number 1. So what is step number 1? To find the oxidation number. So let us consider the central metal atom cobalt as X plus the ethane 1,2 diamine is a neutral one which has got a 0 charge, and even this has got a 0 charge, and that is equal to the overall charge is plus 3. Therefore, X is equal to 3 is the oxidation number of the central metal atom cobalt. The step number 1 has been followed. Let us see what is step number 2. In step number 2, as I have mentioned here, identify the type of ligand. You can observe here the ligands which are here, that is NH3 and EN, is a strong ligand. Can you see, children? Yes, it is a strong field ligand. Therefore, I have identified that it is a strong field ligand. Therefore, the pairing of electron takes place. Let me go further. Now, I will write the electronic configuration of cobalt first. So what is the electronic configuration of cobalt? The electronic configuration of cobalt is right here. I'll just follow, that is cobalt with, that is Ar 3d7 and 4s2. Observe, children, you will understand very neatly. Now, what is the oxidation number we have got? That is 3. You remove 3 from these number of electrons in, that is 3d7 and 4s2. I'll remove 2 from here, 1 from here. Remember, once again I'll repeat it. I have got the oxidation number 3. I'll remove 2 from here and 1 from here. Therefore, what happens? That is Ar 3d6, and this becomes 4s0. So I've got the configuration of 3d6. So I will start filling the electrons. So how to fill the electrons? You might have already learned, you will always start with the 3d orbital. This is a 3d orbital. And then we follow 4s orbital. Then we have 4p orbital. So how many electrons do we have here? We have 3d6. So we have 6 electrons of the central metal atom. I'll start filling those electrons. That is 1, 2, 3, 4, 5, 6. Because it is a strong ligand, strong field ligands are present. Therefore, these electron will shift. I'll just show you the shifting of electrons. You can observe here, this electron will shift here. This electron will shift here. The pairing is taking place. Why? Because it is a strong field ligand. Yes. Then what happens to the next step? If you observe in the next step, I'll just show you how after the shifting of electron, pairing of electrons, what is left. Here it is 1, 2, 3, 4, 5, 6. And here you observe we have 4s. We are left with 4p. And now I will just show you the hybrid orbitals which are formed. So you can observe here the hybrid orbitals which are going to be formed here. I'll just show you. You can observe it. So the hybrid orbitals are going to be, these are the hybrid orbitals. The total number of ligands are 6 here because it is a bidentate ligand. The coordination number is 6. This is a coordination, the En is a bidentate ligand. It is 4. Here it is 2. So totally we require a total number of how much? It is going to be 6 orbitals we require. So I have taken D2, I have taken S1 orbital, and from this side I have taken P3. Therefore, the hybridization is what? This is 4p, this is 3d. So hybridization is what? D2sp3 hybridization. So because all are paired electrons here, there is no unpaired electrons. So what happens to the geometry? The geometry is the magnetic property. Sorry, the magnetic property is going to be diamagnetic property. Yes children, this is how we can find the hybridization of a coordination complex. So I will just show you this trick which we just followed. That is step number 1 to find the central metal atom, the oxidation number of the central metal atom, and then identify which type of ligand. You can just take a screenshot of this trick and you can make use of it. Yes, hope you have done with that, and that's all for today. See you again in my next video. Children, don't forget to subscribe my channel for some more videos. See you again in my next video. Thank you.